Okay, so based on the differencing technique, okay, if we have a trend series, we also can determine whether our trend series is linear trend or uh, quadratic trend. For this example, we will discuss, suppose that we have a linear trend. Okay, if we have a linear trend series, okay, when we perform the first different, it is actually sufficient to perform the first different to change it from non-stationary to stationary series. Okay, remember that if our series has our series has trend component, uh, the series is not stationary actually. Okay, so when we perform the first different or we detrend the series, okay, if we just need the first different, it means that we have a linear trend. If we have the second different, say that, okay, the series has a quadratic trend. Okay, I'll show you example here. Okay, based on our textbook example. Right, so here is the linear trend. Okay, tt equals to alpha plus bt. Right, so when we perform the first different, at the end of the different we get a constant value of beta. Okay, so when we say that we get this when we perform the first different, we get the constant value. It means that now when we perform the differencing towards the linear trend, okay, it is become stationary. Okay, so what if we have this quadratic trend? Okay, so as we can see here, even though that we perform the first different, the t terms here is still there. Okay, the trend component here is still here, is still in the equation, even we already performed the first different. It means that it is not stationary. So again, okay, you can try this at your own. Try to perform the second differencing towards this equation, this quadratic trend. Okay, and see whether you get a constant value or not. If you get a constant value at the end of your differencing, it means that our series is stationary. Okay, your textbook also discuss that most economic series, okay, it is enough for us to perform the second differencing to change our data series from non-stationary to stationary. Okay, uh, right. For this particular slide also, I will introduce you the operator that commonly used to represent this particular notation of differencing notation. Okay, here this operator we call it as backward shift operator. Okay, or B letter, here B letter, and some textbook also use the L letter. Right, so what are these B operator indicate? Okay, suppose that we say BYT. BYT is actually YT minus 1. Okay, what if BYT, it is actually b or equals to b square yt, it is actually yt minus 2. Okay, why we need this backward shift operator? Because it is actually easier for us to sometimes to write the equation. Okay, and later on you will see it is easier for us to use this particular back shift operator to represent the box Jenkins method model, right? Okay, so I hope that you familiar yourself with this particular backward shift operator, and let's take a look at how we write the first order differencing by using this backward shift operator. Okay, let's take a look at the first order differencing data yt, whereby yt minus 1. And then since that we know yt minus 1 is actually byt, so the way to write it is we can factorize. Okay, we can factorize. Okay, 1 minus b, okay, yt. So this is the way, that's why we use this back shift operator. Okay, what the second order difference saying, as we can see here at the end of it, we actually can factorize this 1 minus 2b plus b squared. Okay, when we factorize, we get it is actually 1 minus b, not beta, b backward shift operator square yt. So you have to differentiate the notation, that we use when we represent the order of differencing. Okay, and again, since that the second order differencing is not the same as the lag at particular order, the lag at particular lag order. So when we write the backsheet operator, okay, 1 minus b squared yt is not equals to 1 minus b squared yt. 1 minus b squared yt is actually the difference at d lag here. Okay, so here is actually yt minus 2. Okay, right. So I think that's all for this video. Thank you for listening. If you have any question, you can ask. Okay, bye.